So the next aspect of current electricity we are going to treat now is potentiometer. So let us do what? Potentiometer is potentiometer. So what is potentiometer? Potentiometer is an electrical device that is used to measure the EMF of a cell, or we can use it to compare the EMF of two cells. And we can also use potentiometer to determine the internal resistance of a cell or battery. So let me sit down. Potentiometer. This is a device used to measure EMF of a given cell or what? Battery. Or we can also say what? Or to compare or what? Compare EMF of a given cell. We can use potentiometer to what? To measure the EMF of a what? Of a cell. We can also use it to what? To determine or to compare the EMF of a what? Of a cell. So it can also be used. It can also be used to measure internal resistance of a cell. I think that is what the opposition or flowing of current in a cell or battery is called internal resistance. We can use this device to what? To measure it. So let us construct the potentiometer. After the construction, we explain the principle of or working principle of potentiometer and the application of potentiometer. The first one is what? Construction of potentiometer. Construction of potentiometer. So potentiometer, you can control it by a long wire and a meter rule. So it has long resistance wire of resistance wire of length AB, which is known as what? L. And it's about 10 meter long or 100 what? Centimeter what? Long. About 10 meter what? Long. That is also what? The potentiometer, it has a long resistance wire about what? Length resistance wire of length AB about 10 centimeter what? Long. So we place the wire on a what? On a meter rule, a uniform meter rule, which length is what? Is 10 what? Centimeter what? Long. And the wire is made up of what? Constantine, a Constantine what? Wire that we always what? Use for potentiometer. Let me put it down. Yes. It's yes. It is made of Constantine Constantine what? Wire. Made of a Constantine what? Wire and a battery. And what? Battery of knowing EMF and form the driver cell or primary cell. Mhm. See, the construction of potentiometer, it has a what? A long resistance wire of length what? The wire is what? Is long for 10 meter. You will now place the wire, we will use sellotape to tape the wire on a what? On a uniform ruler of length 10 centimeter wire. And the wire that we use is what? Is made of what? Of Constantine. And the wire will connect. We connect the wire to the what? To a battery of knowing EMF. We must know the value of the what? Of the EMF of the battery. And altogether, the battery that will connect to the uniform, the wire that is well placed on a what? On a uniform meter rule, the battery of knowing EMF, we call it what? Driver cell or primary cell. And the circuit made by the battery, we call it what? Driver circuit. So the last one is one terminal. One what? Terminal cell whose EMF E. EMF E is what? Is to be measured. To be what? Measured is connected to points connected to points A and X. Yes. To point what? A and X in the diagram below. I will draw the diagram now. Well, S and B in diagram what? Below on the meter wire. No, let me add the point of connection. We call it what? Jockey. L and Y. Open bracket. Let me write what? Jockey. Jockey is one that we use to what? To connect it on a meter wire. So, one terminal cell that is what? We want to measure is what? EMF. You know, the first cell that you have here, battery, we know the what? The EMF. You now connect the cell of unknown EMF that you want to measure the what? The EMF to the what? To the meter rule. That is what? Have the meter rule that we already placed what? The uniform wire on it with what? Jockey. With jockey on uniform wire through, yes, jockey through a galvanometer. So the galvanometer will connect this what? Uniform wire to the what? To the galvanometer. This the cell that will be measured will connect it to the what? To the galvanometer. So the galvanometer will now link it to the what? To the wire that we place on a uniform meter rule. So on a meter wire, through what? Through galvanometer and form, this will form a secondary circuit. So if we want to construct it now, just a three step for construction of what? Of potentiometer. So let me now draw the structure of potentiometer. A long resistance wire of length what? AB, which is 100 centimeter what? Long. Let's do that now. Yes. Let me do it in this way. Yes. It's straight. So look at this what? This is a what? A long resistance wire placed on what? On a meter rule. 100 centimeter or 10 centimeter long. So this is a wire. And let's assume that is what we place it. Let me use green marker to represent the meter what? The ruler. This green marker here represents the what? The ruler. And I will place this blue marker represent what? Wire. And here, from here to this will be what? Is 0. And here we have what? 10. So this is the calibration on the what? On the meter what? Meter rule. Good. The blue marker we have here is the wire that we place with sellotape on the what? On this meter rule. A long resistance wire of 10 of wire long of length AB. So that is the length of this wire here is A. No. Let me put it here. The length is what? Is A from here. This point is what? Is point what? Is point B. Good. One is made up of constantin wire and battery of known EMF form a driver cell and driver circuit. So, oh yeah, let me show the what? The battery now. So this is wire. I'm using blue to let wire be. So my wire now, I now connect this blue wire back to what? I will take it up. If I take it up like this with wire, and I will now connect it with a cell. Which cell? Cell of knowing EMF. I will connect it with a what? A cell of knowing what? EMF. Cell of knowing what? EMF. So, if at this point now, I'm having my cell here, and the EMF of this cell is what? Is knowing. Let me call it what? E1. Excuse me. The EMF of this cell is what is known. And so the value for this EMF what we know it. And this is what the cell, the battery. And this battery will supply current to what? To this place, Abi. The next, as I call what driver cell, yes. And I now say what one terminal cell whose EMF is to be measured is connected to a point A and X jockey on a meter wire through a galvanometer and form a secondary cell. Don't forget to let me label this thing. This green represents what? Meter watts. Let me use blue marker to black marker to mark it. This black here there is a meter watt meter rule. And the wire, this blue wire we have here, the blue wire you have here is represent what? Wire. This is what represent what we call what? Cell. Please note that. So what? One terminal cell whose EMF is what? Is to be measured. So I will now place what? Another what? Cell here. The cell I'm placing here, its EMF is what? Is unknown. The EMF of what? Of this cell is what? Is unknown. I will now connect this cell with this what? Meter rule here. So I use another wire to connect what? This cell EMF 2. The value of this one is unknown, is the one that you want to be measured. The value of this one is known. You now use this blue line represents what? Wire. That is, I used to what? To tape to connect to the what? To this wire here. So I use this what? To connect to what? To this wire here. Good. So here now, I will not take what? This EMF, this thing, I will not try to what? To connect it with a galvanometer. This is what? Galvanometer. This symbol represents what? Galvanometer. But here, let me use what? G to represent it. Are we? So, and another wire now join this galvanometer, and at this point here, we have what we call what? Jockey. This is what? Jockey. Yes. And this is what? What? Galvanometer. This one is cell 2. Are we? Good. This is a standard structure of what? Potentiometer. And this point where what? The galvanometer connects to the what? To the meter rule here, to this wire here. The point is called point what? Point X. Why I call the point? Is point what? Point X. This is what? The structure of galvanometer. And don't forget again, the top half circuit we have here, the top half circuit we have up here, we call it what? A driver circuit. While I call it everything we have up here, we call it what? Driver circuit. The top half circuit we have here, everything we have here, let me write it on top. The top half circuit have what? Circuit. The top half circuit, yes, is called driver circuit or primary circuit. So everything on top here is driver circuit, is the one that is supplied current to this. For us to measure this unknown, you call it what? Driver circuit. Everything on top here, you can call it what? Dry what? Let me use head marker for it. Driver circuit. You call it what? Driver circuit. But the bottom half we have here, everything we have here, we call it what? Secondary. What? Circuit. And this one we can also call it primary what? Primary circuits. So this is the structure of what? Potentiometer. So the next thing is what? Let us look at what? The working principle of potentiometer. The working principle of what? Potentiometer. This is construction. The next one is what? The principle of potentiometer, or the working principle of what? Of potentiometer. So if I'm talking of working principle of potentiometer, so the potentiometer, it is work on the principle that, say what? It work on the principle that potential difference across a uniform, across a uniform wire. A uniform what? Wire is directly proportional to its length L, provided the current remain constant. So tell you that what? The EMF of the what? Of the cell is proportional to the what? To the current, to the length of the what? Of the wire on a uniform meter what? Rule. And the current there is what? Remain constant. I can say mathematically that what? The EMF E is proportional to what? To length L. From this expression, we can have what? The EMF E is equal to what? KL. Or for two or more words, sir, this equation, the K is constant, can be what? E1 over L1 equal to the what? E2 over what? L2. So this equation is used to compare the EMF of what? Of two cells. So this is the working principle of what? Of potentiometer. And the working principle of potentiometer can occur in three cases. Distance, AX, CD, in three what? Cases. Let me give you the first case. For the first case, I can say if potential difference of AX is less than potential difference of AD, we know that is what? The potential difference of the wire on this uniform metal A what? AX, if it's less than what? The potential difference of what? Of this length CD, what happened? Let us look at it. Let me draw another what? Potentiometer. Assume this is what? The another potentiometer. This is what it saw. Yes, and I connect it with another E what? EMF with galvanometer. Note that this length here is A what? AB. This place is what? CD. Good. So if my what? Connect my jockey, go to this point here. The point that is I take my jockey to, you can see that is what? The point where my jockey touch on the metal rule is what? Point X. Don't forget, this is still remain our what? Meter what? Meter rule, calibrated meter rule. The what? Calibrated meter rule. And here, excuse me, sorry. This is E what? E1, EMF of second volt, good. What will happen here when the what? The potential difference, the potential what? Difference of VD, let me put it here. Potential difference of V what? VAX is this compared to potential difference of this what? This potential difference of CD, you can see that is what? This Vx is less than what? Vd. This one is more than this. One is less than. So what will happen there? Good. The current that is coming from the side here, I, is going like this. Current I1. The current that is coming from what? From driver cell. This is driver cell or driver circuit. We come like this and move into the what? To this point. The same thing, the current that is coming from the what? From secondary cell. Now, so this one is secondary circuit. The current that comes from the secondary circuit, is also move what? Here, like this, we have what? Current what? I2. So at this junction, current what? I2 and I1, they will move into the what? Into the driver circuit. The current from the primary cell and the current from secondary cell, they will come in together here. They will now enter the what? The, what I call it, driver circuit or primary circuit. So the galvanometer we have inside here, it will what? It will not deflect to this side. The galvanometer what? Will deflect to what? To this side. Let me divide this board. So in that sense, what here the current flow from what driver cell and secondary cell from what driver cell and what secondary cell into what driver circuit. You can see it now. So now go to the what? To the driver what? Driver circuit. This is what? Driver circuit. This is driver what? Circuit or primary circuit. So this is the scenario that is happen when potential difference of AS less than what? VD. In the other case, if the potential difference of AX is greater than the VD, C is the same thing is what? Is the same. Just be looking. Yes. Instead of what? This is E2, Abi. This is what? E1. Good. So instead of this jockey to less than this, you know that what? Let me put distance first. This is A. This is what? B, C, D. So if I now decide to shift my jockey to this what? Side. If I shift my jockey to what? To this point, like this. This point will serve as what? AX. You can see that what? Serve as AS, and my galvanometer will deflect to this side. The galvanometer deflect to that side. This is what will be the meter what? The meter rule. Sorry, let me put it down. This will be the what? The meter rule. Calibrated what? Uniform meter what? Meter rule with 10 centimeter length. Good. So if you deflect like this, and what happened to the what? Direction of the current. If you come like this, Abi, again, this distance here, this is V what? AX. Can you see the distance of VAS compared to distance of CD? Distance of CD here, can you see it? It's less than what? AX. So if this happen like this, here, the current from driver circuit and secondary circuit, or the current from driver cell, primary cell, and secondary cell, they move into the what? Into the driver circuit. But here, if you connect it in this form, your current here, we now move, instead of going to the what? To the uniform wire, no. It will go to what? To current I, it will go to the what? What did I call it? It will go to the secondary circuit. So to have what? I2. So the current will not pass through this junction. It will go to the secondary what? Circuit On getting to the secondary circuit here, like this, it will now go back to what? To driver circuit through galvanometer. The current, instead of at this junction A to going to driver circuit, it will not go. It will what? Go to the what? Secondary circuit. So secondary circuit now add its own current and pass through the galvanometer and now move to the what? To driver what? Driver circuit. So here now, what will now happen here? The current that flow from driver side. So what? The current that flow from driver side, driver side, the flow can flow from driver side, the current that flow from driver, the current flow from driver side, input what? The current flow from driver side to secondary side. From driver side to what? To the secondary what? Or let me put it this way. From driver side to secondary circuit. A driver current flow from secondary side, from driver side into the secondary circuit. Into the secondary what? Circuit. And return into driver side or driver circuit. Driver what? Circuit through galvanometer. Through the galvanometer, return to the what? To the driver side through the what? Galvanometer. So the function of galvanometer here is what? Is used to detect the current. So don't forget, this is what? Driver or primary circuit. So when the current now gets into the what? To this stage, it will now going like this, and backwards to this. So this is the second case. The third case, I will not do diagram for the third case. I will use this diagram to what? To explain the third case. What happened at the third case? At the third case, the potential difference of AX is equal to the potential difference of CD. So when what? Third case, Abi. Let me put it here. Third case, if VAX is equal to what? BCD. That's what happened here. The distance, potential difference between wire of length VAX is equal to what? Potential difference of this length VCD. They are equal. Whenever they are what? They are equal like this, the potentiometer is what? Is balanced. As a result of that, no current flow in the what? In the circuits. Is what? Is balanced, and no current what? Flow in the what? In the circuits. And so what? No what? No current. Current flow. Therefore, the galvanometer will be at what? At middle. This galvanometer sign will stay at what? At middle. This is at what? No current flow. From there, you are now have this formula E1 go to what? I1 go to what? E2 over what? L2. That is all about the what? The working principle of potentiometer. So now let's solve two or more questions on this potentiometer. Then don't forget there are three applications of potentiometer. The first one is what? Potentiometer is used to measure the EMF of a cell. It's also used to compare the two EMF of the cell by applying this formula. Three is used to measure the internal resistance, small r, of the cell. So let's solve these 2 or 4 questions on potentiometer. So the first question is this. Solution. A standard cell of EMF 2 volts, given that E1 is what? 2 volts, is connected to a potentiometer and balance length obtained at 30 centimeter. So the L1, the balance length for the E is what? 30 centimeter. When X is connected to the same potentiometer, when a cell X connected to the what? The same potentiometer, the balance point is 45 centimeter. Calculate the EMF. So when the cell X in volts connect to what? To potentiometer, what is the what? The value unknown. But the length of it is what? Is L2, which is 45 centimeter. What from the principle of potentiometer? What is the formula? E1 L1 equal to the what? EMF2 L2. We are looking for the what? E2. Substitute for each value. What is E1 there? E1 is 2. My L1 is 30 equal to the what? E2. Everything over what? 45. From this expression, we can have 30 E2. 2 times this, we have 90. So we can have what? 30 in 91, 3. E what? E2 will be equal to the what? 3 volts. That's the value for what? For E2. Simple. The second question, we are given a potential in the potentiometer circuit. The cell X has EMF of this. So solution. The cell X has EMF of what? Of this. I say what? EMF 1 is equal to what? 8 points this volts, and the balance length for X and Y are this respectively. As the EMF of this, and the balance point for X and Y is this respectively. Find this. So we can the respectively X is 4, Y is this. That is S length of X. Length of X is what? This EMF of X. Length of S is the 40 what? Is 40 centimeter. Then the E of Y is unknown here. And length of Y is what? 60 centimeter. Using the principle that what? EX over LX equal to the what? EY over what? LY. What is EX? Is 0.8. L is 40. EY is unknown. And 60. By crossing multiply, what are we going to have here? Cross multiply. We are going to end up with what? EY equal to the what? 0.8 times 60 divided by what? 40. So if I press calculator, what am I going to have here? Is 0.8, 0.8, 0.8 multiplied by 60 divided by what? 40. Answer is 1.2 volts. We have 1.2 volts. That is what E Y. This question is an exceptional case. Yes, I forgot to explain the principle. I'll just give you the words here. Just like we applied the what voltage dividers what divider rule. For this kind of question, this is the formula that you'll be using for it. We call it voltage inputs of voltage output. Output will be equal to the voltage input, the total voltage, multiplied by wiper position, which is jockey. Wiper position. Please, if you are getting kind of question, apply this formula. So, for this question now, you can see that we are given the total resistance to be 10 kV connected to a battery of what? 5 volts. This is what? Voltage input, which is source, is what? 5 volts. If a wiper position is 30%, so the wiper position is 30 what percent, it will be 30 over what 100, which is later give us what 0.3. So what will that be the what? The input now, the output. Our output voltage will be 5 volts multiplied by what? And multiplied by 30 over what? Over 100, which is 0.3. Have you now? You now have 35 times 0.3. The final answer will be 1.5 volts. So apply the same principle here, you will get your answer. So using solution, using output, we have to find the unknown voltage. The unknown voltage is also called what? Voltage output is equal to the what? Voltage total, which is what? Input. Voltage total, which is input, multiplied by what? Wiper position. What is input or output voltage? Voltage inputs from the question. The voltage applied is 10 volts. Wiper position is 40. You now have what? 10 volts multiplied by 40 divided by what? 100. 40 divided by 100 will give us what? 0.3. We have 10 multiplied by what? 0.4. By pressing the calculator, the what? Output voltage will be 4 volts. So these are the what? The method or the way of find potentiometer.